Hello, welcome back. I'd like to continue covering the material in Guns, Germs, and Steel. Now, I think if you listen to my first lecture, um, during that lecture, not the first lecture on Guns, Germs, and Steel, but the introductory lecture to the course itself, I suggested that this course is to a certain degree um, uh, a hybrid kind of a course because almost an interdisciplinary course because we are picking up human civilization at the point in which primary sources, which is to say written documents, appear with the invention of writing systems. This book certainly indicates the ways in which, as we push further back into the past, we really rely on a host and a variety of techniques and mechanisms to extract information in the absence of written documents. And what we find that, say, archaeologists refer to as artifacts help us to try and determine the nature of human society, civilization, what groups were grappling with, what were the challenges to humanity at that particular point in time. I'm now getting into chapter 5, which begins to show us some of the ways in which um, the problematic nature of this type of a work is revealed rather nicely by the author, I believe. Although, when you talk about using hard science, physics, for example, as a technique for dating past materials, you face the constant dilemma of whether whether or not the technique you're using at any one moment will be outdated by the advances in the hard sciences themselves. So it's a tricky balance, but the people doing these kinds of work, archaeologists and individuals like Jared Diamond, who's not specifically an archaeologist, um, say, hey, we do the best we can at any one moment, and we are open to revisions, say, in the dating process itself, right? So the first question he's going to begin with is where and when food production began. Now, remember, his major thesis in the book is that in trying to delineate why it is that some peoples, areas, societies are more advanced into the game of modern society than others, have an advantage, these groups then have an advantage on so called tribal and primitive peoples, such that um, we, the representatives of large scale modernized societies, can invade, um, extract resources, even engage in genocide and other kinds of actions. Uh, we need to determine why it was back in the deep past. And so we're talking about maybe 11, 12,000 years ago, where this process seems to first get a very early beginning, what anthropologists call proto agriculture, the first earliest forms of agriculture that would look to our eyes very bizarre and different from what we understand with our modernized systems of field agriculture that spreads, 100 yards, 200 yards, miles across the fields. So he says, okay, in looking at this question of when food production began, and we'll leave the where aside for a moment, um, the first thing you could ask is when a crop, a cultigen, when a crop or an animal were first domesticated. And so, as archaeologists began to sort of move beyond looking for Troy and great cities of the past and really began branching out into a true universal history of humanity, and the issue of something like the growth of agriculture came to the fore. Uh, Things that earlier archaeologists would have literally thrown in the garbage now become central to this dilemma. If, for example, there's a sealed container having something like wheat or barley or peas or whatever, some sort of vegetable there, now with modern systems of analysis, we can determine whether indeed that particular remain um, represents domesticated or wild food stores. Uh, so that if indeed we are looking for the earliest appearance of domesticated plants, domesticated animals, that distinction becomes a critical distinction. Um, is what we have here um, something that a group could have gathered the way hunter gatherers had been gathering wild grains and berries and other kinds of things? Or is it already showing some of the morphological distinctions that human interaction with wild creatures almost subconsciously begins to develop, if you will, um, changes in the morphology, the forms of fruits, vegetables, animals, and so on, so that we can say that, okay, we found here with the items that we are uncovering at this site, we found food remains that suggest, first of all, the bones. It is possible to use bones now with extreme forms of technology today to make a determination as to whether those are wild or domestic, right? And so, the earliest archaeologists would go in and get those bones out of here, throw them out of here. It's just animal bones. We're not interested in that. Today's archaeologist goes, oh, great, we have that. What can we do with it? What indication of the nature of civilization at this point in time, 10,000 years ago? Are we looking at domesticated or wild kinds of species, right? The lack of domesticated plants and animals, where the presence of domesticated plants and animals will indicate the onset of the food production revolution. The absence, on the other hand, would suggest that the group that we are looking at are practicing hunter-gatherer techniques as a system of adaptation to the environment. Now, the next question, which is, again, critical to these aspects of the social and natural sciences, is how do you date them, right? These are randomly occurring sites that have been uncovered, analyzed, classified, and other kinds of things. How do you make the determination of just how old these objects are? And this is when the author gets into a discussion of radiocarbon dating using carbon 14, which breaks down at a certain rate of time into carbon 12. And I know nothing about this. I've never done this, never practiced this, ever read about it, but it's like, okay, I'll let others get involved in this because you need the precise scientific background in both physics and chemistry to be able to handle these kinds of things. But what he indicates to you is a progressive change in the quality of information. And the first thing he says is the earlier forms pre-1980, more or less, the earlier forms of carbon-14 dating required a larger quantity of carbon-based materials. So carbon, the carbon ring, is the chemical basis for all life forms on the planet. Hence, if you study organic chemistry, you'll be looking specifically at the carbon ring and its permutations as it generates more and more complex forms of interaction with other elements to create different life forms over time. And so, in the site that you are analyzing, pre 1980, you needed a larger amount of organic materials. The problem with that is, while you may find a few grains of wheat, a few peas, a few whatever, right? That in and of itself, at that point in time, would have been insufficient to form the basis of a carbon-14 dating analysis. Um, and one of the problems with that is that if you have less than what you need in what you are specifically interested in, and if you're looking at the question of the date at which domestication of plants, the earliest date for the domestication of plants, so we can see where the origins of agriculture really are, and you have an inadequate amount, well, you may take other kinds of organic material that were found together in this site. But, what he says is, hey, these aren't sealed capsules. These are remains that have accrued over time, right? And hunter-gatherers, as we know, will be in a place for a period of time. Once food in the environment becomes scarcer and scarcer, they literally pack up and move what was their home. Maybe, as we saw in the 20th century, sticks stuck in the ground, sticks across the top, leaves on top of that. You stayed there for 4-6 weeks, something like that. And when you left, you left. You just said, okay, we're leaving. They stand up, you get your pouch of arrows. Mama grabs the baby. And if you have an older son, he grabs some stuff too, and we march out and run across the forest to the next place. What I'm suggesting then, and what the author is suggesting then, is what we discover 8, 10, 12,000 years later is not something that has been, protected from contamination by outside events, right? Water flows through it and this kind of thing and carries organic material into it. And so the sense of security in trusting the dates that were achieved at digs prior to 1980 is is lower. We have a lower sense of security in accepting those dates than we would after the 1980s, where they developed new techniques that could then use very, very small particles of organic material to create a much more reliable date for that, right? And then the second thing he throws out is the idea of calibrated versus uncalibrated, which is to say that since carbon 14 is the result of sunlight and solar radiation coming through the atmosphere, and we now understand that the sun does not produce an absolutely constant bombardment of solar radiation on the Earth. It has its own cycles and events and this kind of a thing, which create minor kinds of fluctuations in the degree of radiation, and as a result, in the degree of carbon 14 in the atmosphere that then gets into plants, that then gets into humans who eat either the plants or the animals that have eaten the plants, and then become part of who we are. The use of tree rings, particularly rings of trees and unfortunately we're losing some of those pristine forests in California with what's going on, but there are trees there that sometimes are like 4,000 years old. And if you cut through it, and you hold it up, you will see that trees expand in terms of the yearly cycle producing a ring. And so this is something that, again, um, the coordination of scientists from a variety of fields came together to reveal this fact. And then the archaeologists said, well, damn, this is a guide, right? It's a guide, in a number of ways, right? For one thing, degrees of precipitation. Um, the wider the ring, the more rainfall was available for that tree in that year. So you can really see years in which they were droughts, and you can go if you were to chop down on one of these trees, you could go back 4,000, 5,000 years, however old the tree is, and really look at a year by year basis on patterns of precipitation by looking at the width of individual rings there, and so that sort of these kinds of expanding our human capacity to put things into a temporal framework for something like this is really critical, right? Because if we're trying to determine where it was that agriculture first emerged, being able to date any organic remains that we find in these places, right, will be critical. So out of this will then come the idea of using the information that these experts working together gave us. We can determine the fluctuating patterns of carbon 14, and use that to better calibrate, fix, if you will, the exact date in which an event occurred in the past, right? It has limitations on how far back you can go, but it has enabled us to recalibrate. And as he said, he will be using calibrated dates, which might be different from dates than that you get, say, in a textbook like ours, right? When you say, well, wait a second, over there they're saying this much and he's saying this much, and which one is it? Well, he's at least revealing his hand in what he's doing here, right? Okay. Mm-hmm. So, putting that aside, and it's not something that I'm really expecting you to learn by a brief perusal of what the author has said, but you become aware of, you will have, by reading this, been made aware of carbon 14 and how it might be a critical element in dating past organic materials. We then move on to, once you date the materials, what you want to know then is, how can you know if the domestication that you find in those materials occurred there or occurred first somewhere else and was carried, moved here somehow, right? Okay. And so he gives us then a series of techniques involved here, right? And I think, this man's career is a very unique career, right? And his field of expertise covers a number of different areas that combine social sciences with the hard sciences, with geography and a variety of other things, right? So I'm not sure that anyone listening to this lecture is interested in following his footsteps, right? But I do find it fascinating for you to get a certain inkling, an idea, if you will, of the complexity, but the kind of beauty of it as an attempt to bring together disparate, separate bodies of information to try and answer specific questions, right? So the question is, how do we know where this very, very early example of wheat, for example, is something that was domesticated here, or where exactly was it domesticated? And to look at, the issues that he gives us, right? He said, first you got to start with a map of the geographical distribution of wild species, okay, or wild animal ancestors, right? Um, a field that um, has increased in importance as we become increasingly aware of these processes and how it was that humanity has intervened in natural processes to change the nature of what we have, right? Of the earth itself, that we have been intervening. This is not to engage in the much larger and politically sensitive question of human impact on the environment, but to really look at it intellectually from the larger point of view. How has human interaction with plants and animals actually changed the nature of species so that the animals that we eat today, the plants that we grow and then eat the fruits of today, have sort of evolved from earlier and often very, very different looking wild ancestors. And so this has become, another one of these fields in which modern science trains younger people and sends them out to different parts of the world, you know. And for those people who get hooked, it's exciting work, right? To be out there to try and, discover the earliest forms of maize, for example, the earliest forms of wheat, the earliest forms of barley, the earliest forms of rice, the earliest forms of potatoes, right? To see just what it was at ground zero when humanity makes the takeoff into agriculture, right? And so they have worked at this and developed maps that show the spread and density of wild ancestors. And of course, um, part of that will bring in the genetic scientists. So you bring back samples that the geneticist examines and can truly determine genetically that these plants are the earliest ancestors, or at least the earliest ancestors that we have at the present moment of what today is X, Y, or Z. Hopefully, you understand what I'm saying, right? So you start with a map of the geographical distribution of wild ancestor species of plants and animals, right? Why? Well, there is a basic assumption there. You would assume that the first forms of domestication must have occurred in a region where wild plants and animals existed so that you could use them as the first step up in the direction of agriculture. Is it possible that those ancestors may have died out, may have been removed, um, and may have spread into these other areas? But again, each answer tends to generate a new question as people look at this stuff more carefully. But, the more people we have out there studying it, the greater our knowledge is of the process, particularly as we face the dilemma of an overpopulated planet. And we are concerned with, right now we're concerned with an epidemic, a pandemic that is threatening perhaps millions of people on the planet, right? I think we're probably closing in on 1 million people killed already, right? And we face the threat that with the flu season, this could even get worse than what we've seen already, particularly as people, all of us, get tired of being, stuck in our houses, tired of doing classes like this, all the stuff that goes with it, right? But there are other people out there, just as there have been people. I mean, remember the movie, what was it, Contagion? It's only about 3 years ago, right? God damn, I sat down and looked at that movie and go, oh man, if Hollywood was so aware of this potential and where it could go, right? So many of the aspects of what we're suffering from right now are there, although, they're in broad outline, although our own particular experience may be somewhat different. Um, There are people out there concerned with the threat to the food stores of the planet as we continuously rely on just one or two or three major cultigens. If some sort of an equivalent disease were to strike those plants, say suddenly the rice harvests of the world virtually disappear, right? How many people do they feed? What would happen as a result? Where do we go from there, right? Um, a quick sidelight. Um, my research in Spain covered a situation, since I was really looking at the wine industry, covered a situation that occurred in Europe after 1850, so a century and a half ago, uh, from 1850 to about 1900, um, something called phylloxera. Um, and the phylloxera epidemic was an insect that bored into the grapevines just below the level of the soil. So you didn't see it, but suddenly the plants started dying, and vineyards all over the world were were dying off. And quite honestly, we could, in today's world, be living in a world without grapes or wine, had we not come up with the solution, which was this was a plant louse. The phylloxera was something that had been in North America for centuries, and so the grape plants here had adapted to that plant, and so the solution for all of the marvelous grapevines in France and Spain and Italy and in Greece and other parts of the world where winemaking is a major industry was the need to import rootstock from America, plant that, and after the plant had taken root, then you inherit that. Um, what's that called in English? When you cut the plant open and you put a new variety of plant in, right? They had to do that all over Europe, right? So when you go any place in Europe today, all of the grapevines that you see have as their trunk and base um, American rootstock, but then have had injected into them the varieties that they want to do. That's just that. And you can imagine for a second if indeed wine and grapes had disappeared, our world would look a little bit different. Well, imagine for a second, as we had with the great potato famine in Ireland in the 1850s, where suddenly the same kind of a thing, a blight hit the potatoes, and suddenly Irish society went into chaos. Millions of immigrants from Ireland came here, but went elsewhere as well, to try and escape the fact that people were literally starving in the streets in Ireland, and the English were not doing a hell of a lot to help them, right? Okay, so first thing, you need to map out the distribution of wild species. Okay. Then you need to map out the dates of the appearance of the first forms of these wild species, right? First, get the map, and then go back in and try and see where we have on the map of the appearance of the first forms of domesticated plants and animals, so that we try and try and find the earliest and see it in conjunction with the map of the spread of wild species. So we put one together with the others, and what we come out with is what may well be where that particular item, that cultigen, that animal was first domesticated. Okay. So what the author then moves into is the broad issue of where, when, and how in different parts of the globe domestication occurred, and the food production revolution began. Looping back over his main thesis, which is to try and explain why in the world today there are power differentials between different whole areas of the globe. And the only way we can decipher that is to try and see at what point in time they entered the game of food production and hence begin the process of the development of civilization there. Okay. So to run through this rather quickly, he's going to give us the 5 areas where food production developed independently. In other words, on their own, without any help from any surrounding areas. And so we get the Fertile Crescent, China, Mesoamerica, parts of Mexico, the Yucatan Peninsula, the Andes, the mountains of South America, and the eastern United States as the 5 areas that up to today we have really been able to identify as having sort of developed farming processes in the absence of contact with outlying areas or using what he calls founder crops, right? So there are 4 other areas that are possible candidates, but again, the data is not entirely clear that these 4 areas, produced the agricultural revolution in the absence of assistance from other areas. So we have Africa's Sahel zone, which is the whole Sahara region and parts of that region in different areas where they have discovered this. And indeed, the author then has this on page 95 and puts these maps, puts these areas on a global map. And as you can see there, what he calls the Sahel is really a broad expanse that covers, it's not North Africa, it's sort of northern central Africa. What else does he say? He also says, so we have the Sahel region, West Africa, Ethiopia, and New Guinea. Okay, New Guinea, an island in the Pacific, right? Not too far from Australia. Okay, sort of sitting in the middle there. So, table 5.1 on the next page, on page 96, this table here, okay, this table here summarizes for us in a schematic fashion each of these divisions, right? So the first 5 independent, the next 4 possibly independent areas. And what is nice about it, that particular schematic that he gives us, is that he puts the area together with the cultigen. So we see wheat, peas, olives, the animals, sheep and goats, the date at which this occurred, 8,500 years ago. Doesn't put rye there. Usually rye is included there as well. We see China with rice and millet. We'll get into that when we look at the China material. Mesopotamia, corn, beans, squash. Okay. Andes and the Amazon region, potato, manioc. Eastern United States, sunflower and goosefoot, which I had to look up on I had to Google that. Didn't know what the hell goosefoot was, but I discovered it's a sort of a wild plant that is edible. Interesting to see, right? And anyway, that particular listing is helpful for you to look at to see the way these things sort of fit in around the globe, right? Okay, so what is the conclusion for chapter 5 of this kind of quick look at the issue of where and when domesticated plants and animals made their appearance and where food production may have actually started? So its conclusion is, first of all, only a few areas of the world engaged in food production independently, came to it without assistance from other areas that may have developed food production prior to what they did in that area. So, however, even though there are only these 5 areas, the truth is they occurred at different times, so that the earliest, and you can see this certainly on there, the earliest is Southwest Asia, Fertile Crescent, which is dated as 8,500 years ago. Actually, 800,500 BC, which would make it 10,500 years ago. China, on the other hand, 7,500. Mesoamerica, 3,500. And so we have both distinctive areas, but coming into existence at different times. So only a few areas of the world did this, engaged in the food production revolution independently, yet at the same time they did it at widely different times. So hunter-gatherers then either adopted food production from neighboring groups who were practicing food production themselves, or were replaced by food producing groups. I would put in a third thing there, and I think he sort of mentions it along the way, which is that they will be driven out of their areas, and since they are unable to resist the superior firepower, manpower of societies with the food production revolution intact for them, they will move into peripheral areas, areas that indeed farmers are not interested in. And so gradually farming spreads over the most lush and richest areas, so that by the 20th century, when anthropology tries to get a foot in the game here by going out and analyzing the life ways of hunter-gatherer peoples, something that I've already mentioned, right? These people tended to live in very peripheral, which is to say, areas that did not have a great deal of vegetation, rainfall, whatever it was, right? And so they developed a system of life that was an adaptation to a minimally rich natural environment. And by natural environment, I mean foodstuffs, either in the form of wild plants or wild animals. And so what anthropologists studied in the 20th century tended to be people who lived in areas where they had been forced out of richer areas that the farmers wanted into more peripheral areas. Now, to put this in the context, this conclusion in the context of the thesis of the whole book, what he's going to say is people with head start on food production, those people who get a head start and get into food production first, then have gained a significant, strategically important head start on the path to civilization, and with it, guns, germs, and steel, with which to dominate other people. He then ends by saying, the next question that we need to address is how can we explain these geographical differences in times and modes of the onset of food production itself, which will be part and parcel of my next lecture. Okay, guys.